Hello and welcome to Physics Teacher. In this grade 11 university math tutorial, I'm going to be going over 4 common functions and their key features that you will see used in the beginning of your functions class. So let's get started. The first function is going to be a linear function. So for example, f at x equals x. That'll be the parent function. Okay, so what does that look like? So if we go to Desmos and type y equals x, it just looks like this. Okay, now we can change that function by translating it or changing the slope or so on, but it is basically going to be a straight line. And if you were to look at a table of values, right, for properties of this linear function, so we'll have our x and our y. If we were to have like -2, your value would be -2. -1 is -1, 0 is 0, 1 is 1, 2 is 2. Right? Now those can change if we translate the function or move it or change the slope. But the point is that if you were to find your first differences, so your first differences in your values of the function, right? Your first difference is the difference between -2 and -1. Right? That is just 1. The difference between -1 and 0 is 1. The difference between 0 and 1 is 1. Right? So for linear functions, your first differences are all the same. Now we can certainly change that shape if we did 2x or 3x. You notice you can change the slope, or -2x. Right? And you can also change where it is if you did +3 or -4, right? There's lots of ways to translate or transform it. That being said, do you remember what the parent function looks like? Quiz question number 1. Which of those 3 graphs best illustrates the parent function and why? Pause it here before I give out the answer. Right? So the answer is going to be the second graph. And there's a couple reasons. One, it goes through the origin, right? The parent function goes through the origin. Now this one goes through the origin as well. This one does not. But this one, you can see, has a slope of 3. So this is actually 3x. So it's not quite the parent function. This one is f at x equals x. Whereas this one is simply f at x equals 3. All right, let's move over to our next example. Quadratics. So quadratics we've got our parent function f at x equals x squared. Okay, so drawing this on Desmos, it looks like this. It's our parabola shape that we all remember from grade 10 math, as we did this constantly. So what makes this function special or identifiable? Let's look at our table of values. We'll just do our parent function here. So if we have x and y, if we were to do 0, 1, 2, 3, and 4, we get 0, 1, 4, 9, and 16. So our first differences don't help us a whole lot, as the difference between 0 and 1 is 1. The difference between 1 and 4 is 3. The difference between 4 and 9 is 5. And the difference between 9 and 16 is 7. So that doesn't help us too much. However, if we look at our second differences, the difference between 1 and 3 is 2. Between 3 and 5 is also 2. And between 5 and 7, those are also 2. So for quadratic functions, the second differences are all the same. Now with our quadratic function as well, we can translate it moving it up or down, or we can move it left or right, and we can also stretch and compress, right? Next, moving on beyond grade 9 and 10, we have our radical function. So f at x is equal to the square root of x. So what does this one look like? Here is what our radical function looks like. So notice that it starts off at 0, 0, and it always increases, but the rate at which it increases decreases. Now I want you to imagine rotating that 90 degrees. It looks like half of a parabola. Wonder why that is. Let's take a look at its table of values. So we'll set up our table of values, x and y. But this time, just to make the numbers easier, because I don't want to put in a 2 for x, because then that's the square root of 2. It doesn't give us a nice integer. So to deal with nice, easy numbers, I'm going to choose 0, 1, 4, 9, and 16. So square root of 0, 0. Square root of 1, square root of 4 is 2, square root of 9 is 3, square root of 16 is 4. Doesn't this just look like the table of values for a quadratic, but with the values reversed? And it does. Because we have the square root of something, we're only getting those positive values. That's why we technically only have half a parabola. I could do a plus or minus, right? But if we wrote the function as f of x equals plus or minus the square root of x, well, it's no longer a function. That does look like a perfect parabola turned sideways, but it fails the vertical line test. Right? So we could only have y equals the square root of x or y equals negative the square root of x. We cannot have both. However, we can transform, right? And we can translate as well. So quiz time. We're going to look at the next 3 graphs and tell me which one best describes the parent function and why. Alright, do you have your answer? Our correct answer is the last one. This one's a little bit easier because it's the only one that goes through the origin. But you can also see it goes through the point 1, 1 and the point 2, 3, 4, and 2. Right? Whereas these ones have been both translated and transformed. Right? Let's move on to our last function for the video. And that is going to be our rational function, which is 1 over x, or I like to call it the boomerang function, because it looks like 2 boomerangs. You'll notice it goes through the points here. 1 and 1, I just can't, I almost had it. 1 and 1, there we go. And here are the points -1 and -1. And then you also have our horizontal asymptote at y equals 0 and our vertical asymptote at x equals 0. Now we can change where those asymptotes are. Right? If I did this, then, well, what does x need to be in order to be dividing by 0? Well, -2. Right? If x were -2, you'd be dividing by 0. So there is that new vertical asymptote at -2. What if I subtracted 1 there? Well, now the y value can never get to -1 because that rational will never become 0. And what I recommend you trying is try out the table of values. See why. In fact, let's check it out. If we were to do our table of values of x and y, and we put x as 0, well, what's 1 divided by 0? Undefined. Okay, well, what if I put x as 10? Well, then that's just 1 divided by 10, 0.1. What if I put it as 100? Well, that's 0.01. What about 1,000? Well, that's 0.001. So you can see the bigger x is, it's trying to get to a y value of 0, but it will never get there. And similarly, if x equals 0, there is no y value for the function. Alright, last quiz. which one of these properly represents the parent function of f at x equals 1 over x. Our answer is the first one. It goes through those points 1, 1 and -1, -1, and it has our horizontal asymptote at 0 and our vertical asymptote at 0. Now, although the last one also has those same asymptotes, it is clearly being transformed, and our middle one has been translated as its asymptotes have shifted. I hope this video helped, and if anyone is taking grade 12 physics, for a short time you can download my entire course pack for grade 12 physics for free in the description. Check it out, and thanks for watching.